Okay, class, in this video, we're going to set up 2 more DNS servers, but this time they're going to be integrated in Active Directory. So right now, I have my NAT router booted up, my DC DNS1 booted up, my DC DNS2 booted up, my eDNS1, and my eDNS2. So I'm going to look at our network map. I'm going to pause the video for a moment. So here's our network map. I'm on a different computer, so I don't have the one I edited, but this one is going to be 172.16.0.0. I'll update the map in another video. This IP is 172.16.1, 172.16.0.1. This one will be 172.16.0.2, and this one will be 172.16.0.3. So I'm going to go to DC1, sign in. And while that's signing in, I'm going to go to DC2 and sign in as well. I'm using our standard password. Now I'm going back to DC1. I'm going to go to local server. Now right here, and here is where you would change the IP settings and the computer name. I'm going to do it on PowerShell. New net IP address. Sorry, I hit hit tab too many times. New net IP, then hit the tab key. -I, the tab key. 172.16.0.2 -P, the tab key. That's the prefix, which is the subnet mask. -D, the tab key. 172.16.0.1. I'm going to go back to the map. So the gateway for this computer will be this interface of the router. So when I need to get out of my network, I'm going to send the packet to the router. The interface alias is Ethernet. I'm going to go back to the server manager. The name of the network card is Ethernet. That's all I'm saying. I might have multiple network cards, and you need to tell PowerShell which network card you're configuring. So I'm just going by the name. Hit enter. It's going to say yes to relax your firewall. So I'm assigning my IP address, my subnet mask, and my gateway. The next thing I need to configure is set DNS client S, then the tab key. -S. Before I hit enter, I'm going to go here and show you what I'm doing graphically. I'm setting these two DNS servers. So what I'm going to have these two machines do, and I'm going to do a whole video on this. When these two machines don't know the answer, I need to send the request to these two machines. So if I had a client in my private network that wants to resolve www.contoso.com and sends a request to these two machines, either one of them, it's going to be able to answer that request. But if I had a client on my private network who sends me a request for www.google.com, these two machines won't know the answer because they're not the start of authority for google.com. So I want these two machines to forward the request to these two machines. These two machines, if they don't have it cached in memory, are going to forward them out to machines on the internet. The thing is, I'm going to initially configure those two IP addresses as my DNS client settings. But when I get past this next step, they're going to be reconfigured as forwarders, which I haven't discussed yet. So for right now, this is one of those hear me now, believe me later type scenarios. I'm going to go into detail on why I'm putting my upstream as my DNS client. Because as soon as I go through the process of turning this into the DNS server, it automatically changes these when I'm in an Active Directory environment. I'll get to that. So I'm just going to hit enter and show you graphically what it did. So all I did is configure this. Oh, and this was wrong. I should have been 17. So in this command, this should have been a 17. Hopefully you watched this before moving on, but if you did, it's easy to change. Again, this is going to change once I promote this to a domain controller. I'll go into that. So when I go in here later, after I promote it, this will all be changed. The next thing I'm going to do is rename my computer. Again, I'm pressing tab key. Rename -C tab -N tab. I'm going to call this DC1 restart. I typed R tab. After a while, this will become second nature. You'll be able to start typing entire commands and only hit 15, 16 characters. So you'll get used to it after a while. And you'll only get used to it if you use the commands. If you keep going back to the graphic interface to do everything, these PowerShell commands will never stick in memory. Hopefully you'll keep using these commands and eventually they'll kind of sink in. We don't have a class on PowerShell. It's just a tool. So if you don't use the tool, you won't get used to using it. So I'm going to hit enter. It's going to reboot my computer after renaming. So while that's rebooting, I'm going to go to DCDNS2 and do the same thing. Okay, new net IP net IP tab. Give it a minute. Dash I tab. 172.16.0.3 dash P tab. 16 dash D tab. 172.16.0.1 dash I tab. Ethernet. Hit yes to relax my firewall. Just like when you go to a new Wi-Fi network, it prompts you to whether it's a public network or a private network. So in this scenario, my computer just saw I joined a new network, so it was asking what to do with my firewall. If it's public, it locks it down. If it's a private network, it relaxes it a little bit so you can discover other devices in the network. Now I'm going to set my DNS. Set DNS client S tab -S tab 172.16.0.2. I'm going to go back to my map. These two machines, I'm going to point to here. This machine, I'm pointing to here. So this machine will point to here. This machine will point to here. These two machines will point to upstream servers once I have everything configured. Again, I'm going to do a whole video on that. IN tab, that's the wrong command, so I'm hitting tab again. Ethernet. Rename. So if you just want to look at that, ipconfig /all. You can see that my IP is set, my subnet mask is set, my gateway is set, and my DNS server is set. Rename -computer -new name DC2 restart. So I'm going back to DC1. We're going to sign in. Now this first machine I'm going to do graphically. The second machine I'll do in PowerShell. I need to wait till this bar stops going across. Just like the other machine we've done so far, you configure the IP, you set the host name, you install some software, then you're going to configure it. We've configured the IP, we configured the host name, now we're going to install some software. Add roles and features, and we're going to turn this into a domain controller. Active Directory domain services. Not only are we going to install the Active Directory domain services, we're going to install all the tools to manage that. Click Next. Restart if necessary. Click Yes. In this case, it is necessary. Click Install. So while that's installing, I'm going to do the same thing to DC2. Using our standard password. I'm going to open up PowerShell. While it's opening up, I'm going to pause the video. I need to wait till this blue bar stops before I can do anything else. Okay, the blue bar is stopped. Now I'm going to install the Active Directory domain services, but this time through PowerShell. If you don't know the name of the software you want to install, you can type git-windows. Now I'm going to press the tab key to autocomplete. Windows feature, I'm going to do AD asterisk. So it's going to show me all the stuff that starts with AD, Active Directory. So what I want to install is Active Directory Domain Services. And you'll notice that there's a lot of commands where the verb at the beginning changes. You would have get Windows feature to list all the Windows feature and new hyphen Windows feature to install something. So install instead of get, install Windows feature. The name, which I got from this list, is AD Domain Services. You can't tab through that. You have to type it out. -IN. I hit tab multiple times. I want to get to include management tools. Just like the pop-up in the graphic environment, this is that pop-up. Dash restart if needed. In this case, it is needed. So guys, after a while, this one command was the same as me walking through that entire wizard. So you'll see over time that PowerShell is a lot quicker to do things. You know, for your benefit, I ran the git command. I didn't need to do that because I already know this from doing it so many times. So over time, you'll remember what the command is and you won't need to do the git command. You'll just come in and run that. Okay, so while this is installing, I'm going to go back to DC1. So now all the software is installed. I need to configure it. So I'm going to promote this machine to a domain controller. Keep in mind the term domain in this context means a security domain. Like a lion's domain in Africa would be the area that he roams, the area that he secures. So I'm going to click promote and then I'm going to create a new forest. A forest is a collection of trees. A tree is a collection of domains with contiguous namespace. So if I had a contoso.com as a domain, and then I had a child domain underneath that, child.contoso.com, that would be a child domain. The child domain includes the parent names. So that's what's telling me it's a contiguous namespace. The child domain includes the parent domain. I could have another child underneath that called sales.child.contoso.com. That would all be part of the same domain. I could have a new domain underneath our forest called adatum.com. Because it doesn't include the parent name, that would be a new tree within that forest. This topic is covered in the next course. So a forest is a collection of domains. A forest is a collection of trees. A tree is a collection of domains with a contiguous namespace. So contoso.com would be the beginning of one tree, and if I had another domain called adatum.com in the same forest, that would be beginning of another tree. So when we walk through this wizard the first time and we create a new forest, we're going to be creating a forest called contoso.com. In that forest, we will also be creating a tree called contoso.com. And then we're going to be creating a new root domain called contosa.com. So in this one wizard, we're going to be creating a new forest, contosa.com, a new tree called contosa.com, and a new domain called contosa.com. The forest is a container that contains trees, tree objects. A tree is a container that holds domain objects. A domain is a container that holds user and computer objects, and amongst other things. But just to give you an example. So I'm going to create a root domain called contosa.com, in a forest called contosa.com, in a tree called contosa.com. Click Next. I'm not going to go into this, but in Active Directory, without a DNS server, no one will be able to find anything. And the whole lesson that we're doing right now is DNS. The thing about this Active Directory, it's going to configure this DNS server for us automatically. We're going to put in a recovery password. And I'm using our standard password, capital PA11WRD. Now here is something that you need to be aware of. When you create a domain controller on a machine, when you turn it into a domain controller, it doesn't have any local user accounts anymore. So if I join a computer like this DHCP to our domain, that machine will have local user accounts and domain user accounts that can be used to sign in. So every computer that I join to the domain will have two sets of user accounts they can use to sign in. Domain user accounts and local user accounts, except on the domain controller. The domain controllers will no longer have local user accounts. So if my Active Directory database crashes, I need one password to be able to sign in to fix Active Directory. And we call that Active Directory Restore Mode password. Every iteration of Windows, they change this name. It's always been the same purpose though. This will be one user account name, that one user account password that we can use to sign in if Active Directory fails. When I change the domain admin's password, it doesn't affect this password. This is separate. Each domain controller will have its own directory service restore mode password set, and it doesn't always need to be the same. So you need to make sure when you go into a company, you know what that password is, why the DC is up and running. If the DC crashes and you don't know that password, you won't be able to get in to fix it. So if you don't know the password when you go start working for a new company, you need to go into the sign in as a domain admin and reset this directory service restore password to something you know and keep it in a secure location. I'm not going to explain what this delegation is, but because that's a whole nother lesson. Basically, it's trying to contact eDNS1 and eDNS2. It's trying to create another zone for this contosa.com domain. It doesn't have the authority, so it's failing to do so. So this is an error we want to see. So basically, because it failed, this process will automatically know to configure DNS on this machine and automate everything for us. It tried to contact these two DNS servers because that's what we put in the DNS client settings. It's going to fail, and at that point, configure the DNS server directly on this machine, which is what we want to happen. Netbios was an old form of name resolution that uses broadcasts to resolve names to IPs. It wasn't very efficient, but it's still here for backwards compatibility. So if your DNS server goes down and all the computers are in the same subnet, they can try to broadcast and find out the names, find out the IPs of certain computers. Old form of name resolution, don't really use it anymore, but it's still around. So we have three important folders when we promote this. Our Active Directory database, all the things that we changed that we create an Active Directory will be stored in this database. Like when you create a new user, it's going to be stored in this database. The thing is, we don't make changes to that database. When we make a change to this transactional log file. When it's safe to do so, it'll copy it to the Active Directory database. Once it's in the Active Directory database, it'll replicate that database to another domain controller. So when we create a new user account or make a change to a user account, we change it in the log file. When it's safe to do so, it will copy that information to the database. When it's safe to do so, it'll replicate that database to another domain controller. Lastly is our Sis File folder. Every time a computer boots up, it will try to find a domain controller through DNS. It'll query the DNS server and find a domain controller, and then look for policies in this shared folder. So every time I create something called a group policy, it's going to be stored in this location. And then when I boot up a client computer, it'll go to this location and download the policy and apply it to the computer. The thing is, this is called a junction point. It's not a normal network share. Once it's set up, it won't be a normal network share. This is going to be tied to all the sysvol folders on all of the domain controllers. When I make a change to one, it automatically gets replicated to all other domain controllers. So if I'm on one DC and I create a new group policy, that's going to be replicated to all the domain controllers because it's going to be stored in the sysvol folder. Don't mess with this folder. If you grab this folder and you copy it to your desktop, from that point on, that folder on your desktop will be part of your replication cycle and you can never shut down that desktop. So you never want to mess with this folder. You don't want to copy it because if you copy it, you're not copying a normal folder. It's a junction point. So basically, you'll be adding yourself as a replication partner. That copied folder will be adding itself as a replication partner to all our domain controllers. Again, this is going to be discussed a lot more detail in the third class. This is a review of everything we just set. Click Next. It did a prereq check, made sure this machine was sufficient enough to run a domain controller. Now I'm going to click Install. That's going to take a few minutes, so I'm going to pause the video. Okay, it's promoted to a domain controller, so now I'm going to sign in. Notice that I'm signing into the domain at this point. I'm going to go to local server. And I'm going to look at the IP settings first. Look at the DNS. When I initially set this up, I set it up to go to 172.17.0.2 and 172.17.0.3. Now after I promoted it, it's telling this DNS client to talk to the DNS server on the same machine. So it's pointing to the loopback address. So the only way a DNS server and a DNS client will have the same information as if you point that DNS client to the DNS server on the same machine. So now I'm going to go to Tools, DNS. Now if I look at my forward lookup zone for Cardoso.com, I have a lot more records here. And I can see that my NS record is already complete. My SOA record is already complete. I have a host record for my machine, all done for me. So if I go to underscore TCP folder, I can see I have something called a global catalog server, a Kerberos server, a K-password server, and an Ldap server. For all intents and purposes, these are the things that make up a domain controller. So in later classes, in later videos, we're going to join computers to the domain. We're not going to specify who the domain controller is. All we're going to say is the domain. The client will use DNS to find out who the domain controller is, and it's going to query these records. So I'm going to open up a command prompt. Actually, I'm just going to open up a regular command prompt, not a PowerShell. Actually, I'll open up a PowerShell because that's probably most likely what you'll use. Keep in mind that if you use Nslookup in PowerShell and you're talking to a non-authoritative server, meaning I'm talking to a server to get an answer for a machine that's not the SOA, the start of authority. So this machine is the start of authority for Contoso.com. But if I try to connect to this machine and resolve Google.com, it'll generate an error, but it's no big deal that you get that error. So I'm going to go into Nslookup. And now I'm going to type exit just to show you something. ipconfig/all. I have two DNS servers, ::1 and 127.0.0.1. I'm going to go to my IP settings. If I look at IPv6, ::1 is telling this IPv6 DNS client to point to the server on the same machine. That is the IPv6 equivalent of the loopback address. ::1 is the IPv6 version of 127.0.0.1. So that's my primary DNS server, and my secondary DNS server is the IPv4 loopback address. So my primary DNS server is the IPv6, and the secondary DNS server is the IPv4. So I'm going to go back into Nslookup. And it automatically connects me to the IPv6 loopback address. So I'm pointing to the same server on this on the same machine as my client. I'm going to pull up my DNS. In the standard DNS server, we didn't deal with service records, but in Active Directory, we deal with service records. I told you DNS can do two things: resolve a name to an IP, and the second thing is an IP to a name, and the third thing is resolving a service to a name and IP. So if you want to find out who the domain controller is, that's going to be a service to a name to an IP. You need to find out which server is offering that service. So we're going to do a query of a service record. So I'm just trying to pull the server to the side so you can see what I'm doing. So the type is what? Set type, because normally when I go in here, it resolves A records, which is a name to an IP. So now I want to search for a service record. So the service record would be, I want to find out who the global catalog is. for this domain. And that's who's the global catalog server. So I'll put underscore gc dot underscore tcp/ip, underscore tcp dot contoso.com. This is in this folder. This is in this folder. So you have to put the fully qualified domain name of that service record. Your global catalog is a mechanism to search the entire forest for objects. So if you're in one domain and you want to find out information about a computer in another domain within that same forest, you're going to talk to the global catalog server. Your Ldap server is lightweight directory access protocol. That's your Active Directory database. So if you need to find out who your Active Directory database is, again, I'm still searching for a service record, would be underscore Ldap dot underscore TCP dot contoso.com. And right now I only have one Ldap server and one global catalog server. Your Kerberos server is the service that grants tickets. Let's say I have a file server, this DFSR1 or DFSS1. They're file servers. So if I had a client that wanted to connect to one of these file servers, it doesn't talk directly to the file server initially. First, it's going to go to the DC and tell the DC it wants to talk to these file servers. The DC is going to verify that that user account has permission to talk to these file servers. If it does, the DC is going to give the user account a ticket. And that user is then going to take that ticket and present it to the file server. If the file server verifies that ticket, meaning if it was signed by the DC, it lets that user in. So the user never presents his name to the file servers directly. They present the username to the DC. The DC will then give them a ticket that will expire quickly, and that user will then present the ticket to the file servers to gain access. So that's what the Kerberos server is. So all these things together make up a domain controller. The clients will know who the domain controller is by querying DNS for service records. If it needs the global catalog, it's going to query the DC for the global catalog. If it needs to know who the Ldap server is, it's going to query the the DNS for who the Ldap server is. If it needs to know who the Kerberos server is, it's going to query DNS to find out who the Kerberos server is. So without DNS properly functioning, clients wouldn't be able to know how to find a domain controller or any services on the network. So it's important that you have a properly functioning DNS server. I'm going to type exit here and do ipconfig all. So when I initially set this up, I set the DNS servers up to be 172.17.0.2 and 172.17.0.3. So where did those IPs go? So I'm going to highlight my server and go to forwarders. It took those two DNS settings, client settings, and made them forwarders. So basically, it took my client and made my client point to the same server. Excuse me. It took my client and pointed it to the server on the same machine. Now, if the server doesn't know the answer, this is who the server will go to looking for an answer. So if my client on this machine connects to my server and says, give me the IP for www.google.com, the server's not going to know because the server isn't the start of authority for Google.com. So the server has to talk to someone else. That's what these two machines will be doing. Once we're done with both DC1 and DC2, I'm going to do a whole video on forwarders. The client will talk to this server. If this server doesn't know the answer, this server will talk to these two servers. If these two servers don't know the answer, they'll talk to a server out on the internet. So it's a whole chain of servers that are talked to, and it can happen like in a few seconds. It can literally talk to 30 servers without you even knowing it to get the answer that you need, because there's a whole chain of DNS servers that it needs to talk to resolve a name to an IP. Again, I'm going to go over that. It's a very confusing topic. So I'm going to exit out of here. And so for my forward lookup zone, I didn't really have to configure anything. I didn't have to create any host records. I didn't have to create the SOA record, the ANIS record. Everything is done for me. The thing it didn't create was the reverse zone. The forward lookup zone will resolve name to IPs, but we don't have anything that resolve IPs to names. So I'm going to create two zones, one for this private network and one for this DMZ network. So I want to resolve any of these IPs to names and any of these IPs to names. So I'm going to create a new zone. It's going to be a read-write copy. But instead of storing all the information on a text file like we did on these two DNS servers, it's going to store it in the Active Directory database, which makes it a lot easier in maintaining the other servers, because once it's in that Active Directory database, any other DC can access that database and get all the records. So in a standalone DNS environment without Active Directory, I have one machine that's read-writable. The other is just a copy. It's read-only. So in this scenario with Active Directory, all my DNS servers are read-writable because the changes aren't being made to a text file that's on one server. It's being done in the Active Directory database. So if a user connects to this DNS server, they can make a change and it's stored in the Active Directory database. And if someone connects to this DNS server, they can make a change and store it in the same Active Directory database that's replicated between all the domain controllers. When we did this initially, this was grayed out because we didn't have Active Directory installed. But now it's installed, so it'll store all this information in the Active Directory database, not a text file. And we want this to be replicated to all the domain controllers in our forest. Well, this is actually domain. I could do this and say all DNS servers in the forest, or only the DNS servers within this root domain called contosa.com. It's going to be for an IPv4 network. And the first network ID is 172.16. I'm going to go to my map. That will represent all the IPs in this network up here. Next, I'm going to allow dynamic updates. In the standard DNS servers, we didn't allow dynamic updates because we had no sort of security control. So what this is basically saying is, if you're joined to the domain, we're going to trust you to connect to the DNS server and create any A records or pointer records you need for each client automatically without the domain admin having to get involved in manually creating them. Next, then finish. So I'm also going to do one for the DMZ network as well. New zone. Next, it's going to be primary. I'm going to copy it to all DNS servers in this domain. It's going to be for an IPv4 network. And that network ID down there is 172.17. That will represent all the IPs in this network. I'm going to allow dynamic updates. If any of these machines are joined to the domain, they'd be allowed to automatically add themselves. Finish. So if I go into the first one, I can see that the SOA record is already complete. I can see that the name server record is already complete. But if I try to do Nslookup, I'm going to look for a pointer record, set type equal PTR, and then I did 172.16.0.2. That's the IP for this server. The problem was when this server booted up, this reverse didn't exist, so it wasn't able to create a pointer record for itself. So I'm going to press exit. I can type ipconfig / register DNS. It will contact the DNS server and register any records that it's missing. So I'm going to go back to my reverse. It's in this subnet, 172.16 subnet. Hit refresh, and I can see I have the pointer record. So it automatically created that for me. If I rebooted this machine, I would have had the same effect. It would have, when I rebooted, it would have contacted the DNS server and created any records that it was needing. Guys, this is the old school DOS command. For PowerShell, it would be register DNS. Sorry, I hit tab too many times. Register-DNS client. This in this command does the same thing. This is PowerShell. This is old school DOS command. So again, I'm going to come back here. We're going to talk about forwarders a lot more. We're also going to talk about root hints, and that's going to be on another video. Okay, so the next thing I'm going to do is I'm going to exit out of this box, close this down, and I'm going to promote DC2 to be a domain controller in this domain. Now, in this particular case, I don't need to create a new forest or new tree or new domain. They're already existing because I promoted it up here. So in this one, I'm just adding a second domain controller to an existing forest, existing tree, and an existing domain. So this is just going to be another copy of DC1. There are some changes, but we're not going to get into that until the next class. There are some differences, but for all intents and purposes, DC1 and DC2 are going to be equal. So I'm going to do it on PowerShell though. I'm going to do install-AD tab. I have domain. That'll create a new domain. Hit tab again. That'll create a new domain controller in an existing domain or new forest. So I'm hitting shift tab to go backwards. So this one will add a new domain in an existing forest. This one will add a new domain controller to an existing domain. And this one will create a new forest, which will also create a new domain. Excuse me. It'll create a new forest, which will also create a new tree, which will also create a new root domain. That's what we did on the first machine. What I want to do is this one. I want to create a new domain controller in an existing forest, in an existing tree, in an existing domain. So the domain name is contoso.com. The credentials. Sorry, I couldn't remember the switches, so I just kept hitting tab. If you don't remember what comes next, hit hyphen, then keep hitting the tab key until you see the command that you want. So I need to supply the credentials. So what I'm going to do is I'm going to run a second command within this first command. I'm going to nest one command in another. I'm going to say get hyphen credentials contoso backslash administrator. So what this command does is it pops up a dialog box and asks you for the password. Then once you click OK, it'll save all that as an authentication object and pass it to the credential switch. So this is a separate command nested in this big command. So before it executes the big command, it's going to execute this little one, the nested one first, throw up a dialog box, ask me for the password. Once I hit OK, it'll take the user account name and the password and create an authentication object that will pass to this switch. The last thing we need to do is, guys, I didn't hit enter, it wrapped around. It's apply that Active Directory restore mode password. That's all I need. I'm going to supply the domain name for the domain that I want to create a new domain controller for, supply the credentials, and the Active Directory restore mode password. But I screwed up. In these commands, I cannot supply a plain text password. I have to encrypt the password. So I'm going to create a variable called password. And I'm going to run a command. Convert to secure string. This command will take a text password and convert it to an encrypted password. So basically, I'm going to run this command. It's going to take this plain text password, encrypt it, and then save it in this variable called password. So all that did was create an encrypted password. Now I need to run this command. Sorry guys, I needed to encrypt the password before I did the other. Yes, now it's not working. Sometimes it gets a little screwy and you don't see the switches. If it doesn't see it, just type it out. Domain name is contoso.com. Credentials is get credentials. And the save mode password is $PWD. That will pass my encrypted password to this switch. Because if you try to run this command with a plain text password, it's just going to generate an error. So I'm going to hit enter. See, now this is being ran right here. It threw up this dialog box asking for my credentials. Capital P-A-11-W-O-R-D. think I typed that wrong again. Okay, this credential switch isn't going to accept a user account name and password. What it needs is an authentication object. So this little command right here, I'm supplying the user account name and password, which auto fills into that box. Then I supply, the domain name and the user account name, and it automatically fills in that box for me. If I left this blank right here, I would have had to type it up here. So all that does is take this information, puts it up there. I supply my password. No one can see me typing the password other than me verbally saying it out loud and recording it and posting it on the internet. But this command will take my user account name and my password and create an authentication object, which is what this switch is looking for. It's not looking for a user account name and password. It's looking for an authentication object. This command right here will create that authentication object. Click OK. So I don't know why this is not working. Oh, I'm sorry, guys. I should have been running ADDS domain controller, not ADDS domain. That's why I didn't find the switch. Sorry, I was running the wrong command. Hit yes for all, or A for yes for all. And now it's going to promote it and then do a reboot. Because remember, the reboot that it's going to do, I can't show you because it's behind the screen. But when we installed the software, we said restart. That's where it's getting the reboot. This doesn't take as long because it doesn't have to create the whole forest. All it's doing is just adding a new domain controller to the forest. There's the command that we ran. Do this command first to encrypt your password. Do this command to promote it to a domain controller, and now it's going to reboot. I didn't click anything. I didn't do anything. I just let it alone and it's rebooting on its own. I'm going to pause it while it's rebooting. Okay, it's promoted. So I'm going to sign in. Again, I'm not signing into the local computer. I'm signing in with a domain account. All this Active Directory stuff is in the next class, not this one. We'll do that class in the second half. So I don't want to go too detailed into the Active Directory stuff. While that's signing in, I'm going to go jump to DC1. I'm going to go to DNS. If I look, I now automatically have a record for DC2. I have an A record. If I look in the reverse, in this network, I have a pointer record for DC2. If I go into contoso.com, TCP, I now have service records for DC2. So if I open up a PowerShell and do an Nslookup, I want to close this out for a second. If you want a quick way to get to Nslookup, you highlight your server, go to Action, and launch Nslookup right from here. That automatically open you up directly in a command prompt. So I'm going to do set type equal SRV because by default the type is set to A, and I can do underscore global catalog dot underscore TCP dot contoso.com, and I can see that it now gives me two global catalog servers. If I did Ldap, it'll give me two Ldap servers because now I have two domain controllers. So when a client queries DNS for an Ldap server, it can go to either Ldap server. It doesn't matter. They're all equal. So if I go to DC2 DNS2, and go into DNS on this machine, it's automatically configured. I didn't need to create a secondary or anything like that. It pulled all this data from the Active Directory database. So when I make a change to either DNS server, it's going to automatically be copied to the other DC through Active Directory replication. No administrative effort on my part is needed. You create the zone once, you don't need to create secondaries because if it's part of Active Directory, this DNS utility will automatically go to Active Directory and pull that data out of it. Okay, guys, we still need to have another video on forwarders. We'll talk about this. We need that same video. We'll talk about the root servers, and I need to turn these into a different type of DNS server for my DMZ. I'll explain that when I get to it. So I probably have one more video on this topic. Okay, that's it for this video. I will see you in the next video. Thank you.